Hello students, today we will be seeing relations and functions exercise. A disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the same. Thank you. Here's our question. Show that given function from r star to r star defined as fx is equals to 1 by x is 1 1 and on 2, where r star set represents the set of all non-zero real numbers, meaning all real number except 0. Is the result true if the domain r star is replaced by set of naturals, with codomain being the same? We just If we just replace the domain set by naturals and codomains remains the same, is the result true? You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So we have to show the given function is 1 1 as well as on 2 on the given domain and codomain. If we change the domain, is the result same? Solution: given function fx is equals to 1 by x from r star to r star. For 1 1, we start with fx is equals to fy, and we have to show that x1 is equals to, in this case, x is equals to y. Imply 1 by x is equals to 1 by y, imply x is equals to y. So f is 1 1. For on 2, what we have to show is for any element from codomain, there exists an element from the domain such that f of x is equals to y. Simple. In other words, it is clear that y belongs to the codomain set. There must exist. So we are saying there exists x of the form 1 by y. Of the form 1 by y such that what is happening? F of x is equals to y. As you can see, f of x is equals to 1 by x is 1 by y, so you are getting y. So if you pick any element from the codomain set, there is pre-image in the domain set. I hope it is clear. So on to. Now, therefore, f is on to. Simple. So our function is 1 1 as well as on to. Now consider function n to r star defined by gx is equals to 1 by x. So gx1 is equals to x2 in order to show 1 1. So gx1 will be 1 by x1 and gx2 will be 1 by x2, gives me x1 is equals to x2. So therefore g is 1 1. But g is not onto y. You know 1.2 belongs to the codomain set. Yes, but there does not exist any element from the domain set such that g of x is equals to 1 by 1.2. Clear? We do not have any pre-image for this element. So not onto. Hence the function g is 1 1 but not onto. So the result is not going to be the same. I hope solution is clear to you. Now, this question, we have to check for injectivity and surjectivity of the given functions. Injectivity meaning 1, 1, surjectivity meaning on 2. So, in first function defined from natural to natural by x square. Second function defined from integer set to integer set fx is equals to x square. In third function defined from real to real fx is equals to x square. In fourth function defined from a natural set to natural fx is equals to x cube. And in fifth function defined from set integers to integer set defined as fx is equals to x cube. You will have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. So we have to check for the injectivity and surjectivity of the given 5 following functions. Solution. Starting with the first function defined from set of natural to set of natural fx is equals to x square. We can easily see that if you pick any two elements from the domain fx and starting with fx is equals to fy, then what we are having is simply x square is equals to y square. And from this you will get x is equals to simply plus minus y, but as we are taking x and y both from set of naturals, so you will get the condition x is equals to y. So it is injective. Clear? Now observe 2 belongs to the set of codomain set, but there does not exist any x in the domain such that fx is equals to 2, meaning we do not have any x such that x square is equals to 2. Why? Because if you solve this you will get plus minus root 2, and root 2 doesn't belongs to set of naturals, so not on 2. Therefore not surjective. Hence function is injective but not surjective. Now for second, function defined from set of integers to set of integers fx is equals to x square. It can be easily seen. For two different inputs we are having the same output, so not 1 1. So f of minus 1 is equals to f of 1, but we are having minus 1 not equals to 1. So it is not 1 1, not injective. Not injective. For second part, so taking minus 2 from codomain set, we observe that there does not exist any element from the domain set such that f of x is equals to minus 2 or x square is equals to minus 2. We know that if you have any real number, then square of it will be the positive number. We cannot have negative. So no pre-image of minus 2. F is not surjective. Hence function is neither injective nor surjective. Third, function defined from set of reals to real given by fx is equals to x square. So it can be easily seen it is not 1 1. Why? Because f of minus 1 is same as f of 1, which is 1, but minus 1 is not same as 1. So you are having same output for two different inputs. So not 1 1, not injective. Now picking a simple minus 2 from the codomain set, minus 2 from codomain set, then There does not exist any x from the domain set. There does not exist any element from the domain set such that fx is minus 2. Why? Because we do not have any real number whose square is negative. So, not surjective. Hence, function is neither injective nor surjective. Fourth, function defined from set of naturals to naturals. Given y fx is equals to x cube. Picking any two elements from the domain set, we set up fx is equals to fy, which is x cube is equals to y cube, and this gives me the condition that x must be same as y. So this whole sentence, this whole line gives me or fulfilling the condition for 1 1. We only have the same output when we have the same input. For two distinct input, we are not going to have the same output. So 1 1. So therefore, your defined function x cube from n to n is injective. Now for surjective, picking 2 from codomain set, we observed that there does not exist any x from the domain such that fx is equals to x cube, which is equals to 2. Therefore, f is not surjective. Clear? Now, so we can easily conclude that the given function from n to n, fx is equals to x cube, function is injective but not surjective. Clear? Now for fifth part, function defined from set of integers to set of integer. Fx is x cube. In order to show 1 1, we start with fx is equals to fy. X and y both belongs to the domain set, and we need to show that x is equals to y. So x cube is equals to y cube. So we are getting x is equals to y, meaning our given function is 1 1. So therefore f is injective. Now picking 2 from codomain set, we observed that there does not exist any element in domain such that fx is equals to x cube, which is equals to 2. Therefore, f is not surjective. Hence, the given function from z to z, fx is equals to x cube, is injective but not surjective. I hope it is clear. This question, prove that the greatest integer function f from R to R given by fx is equals to box x is neither 1 1 nor onto, where this box x denotes the greatest integer less than or equal to x. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So in question, given function, we have to show that it is neither 1 1 nor onto. Solution. Function defined from R to R as fx is equals to box x, and this box x represents the greatest integer less than or equal to x. It is easy to see, for input 1.2 the output is 1, for input 1.9 the output is the same 1. So for two distinct inputs we are having the same output. So not 1 1. Clear? So not 1 1. Therefore f is not 1 1. Now consider zero point 0.7 from the codomain set, and we know this box X is defined in such a way that the output is always an integer. Thus there does not exist any element from the domain set such that fx is equals to 0.7. Therefore f is not onto. Hence the greatest integer function is neither 1 1 nor onto. Clear? This question. Show that the modulus function from R to R given by fx is equals to absolute of x is neither 1 1 nor onto, where mod x is x if x is positive, 0, and mod x is minus x if x is negative. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So we have to show the modulus function is neither 1 1 nor onto. Solution. Starting with the given function, fx is equals to mod x. Piecewisely we can write x, this mod x is x when x is greater than equals to 0, and mod x is minus x when x is negative. So it can be easily seen that f of minus 1 is 1 and f of 1 is 1. So for two distinct inputs we have the same output, meaning f is not 1 1. Now consider minus 1 from the codomain set. We can, by definition, it must be clear that the output or fx will always be non-negative. So there does not exist any x from the domain set such that fx is minus 1, because this will always be non-negative. I hope it is clear. Therefore f is not onto. Hence the modulus function is neither 1 1 nor onto. Now this question. Show that the signum function defined from R to R, fx is equals to, defined as fx is equals to 1 when x is positive, 0 when x is 0, and minus 1 for x negative. And this signum function is neither 1 1 nor onto. Show that. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So we have to show that the given signum function is neither 1 1 nor onto. Solution. Function from R to R defined as fx is equals to 1 when x is positive, fx is 0 when x is 0, fx is minus 1 when x is negative. We can easily see that f of 1 is equals to f of 2, which is 1, but 1 is not same as 2. Therefore f is not 1 1. Now fx takes only 3 values, 1, 0, minus 1 For the element -2 in codomain, there does not exist any x in the domain set such that fx is equals to -2. Therefore, f is not onto. Hence, the signum function is neither 1, 1 nor onto. I hope it is clear. This question. Set A with element 1, 2, 3 and set B with element 4, 5, 6, 7 given to us. And f function is defined as collection of all pairs 1, 4, 2, 5, 3, 6. These three pairs from function from A to B. We have to show that this given function in roster form is 1, 1. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So in question, we have to show that the given function from A to B is 1, 1. Solution. It is already given to us that set A, which is a domain set with element 1, 2, 3 and B codomain set with element 4, 5, 6, 7. So from set A to B, f is defined as 1, 4, 2, 5, 3, 6, which gives me what? That 1 is associated with 4, 2 is associated with 5 and 3 is associated with 6. So for input 1, f of 1 is 4, for input 2, f of 2 is 5, for input 3, f of 3 is 6. So it is seen that the images of distinct elements of A under F are distinct. Hence, F is 1, 1. This question. In each of the following cases, state whether the function is 1, 1, onto or bijective. First, function from R to R defined as fx is equals to 3 minus 4x. Second, function from R to R fx as 1 plus x square. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So we just have to state whether the given function is 1, 1, onto or bijective. Solution. For first, domain set is R, codomain is also R. Fx defines as 3 minus 4x. So picking x1, x2 from domain set and setting up fx1 is equals to fx2. We are having 3 minus 4x1 is equals to 3 minus 4x2. Gives me x1 is same as x2. So therefore f is 1, 1. Now picking any element from the codomain set y, there exists 3 minus y by 4 which belongs to the domain set such that f of 3 minus y by 4 is equals to y. Therefore f is onto. Hence our function is bijective. When function is onto as well as 1, 1, then we say our function is bijective. For second part, f defined from R to R, fx as 1 plus x square, starting with two elements from domain set and setting up fx1 is equals to fx2. Now fx1 is simply 1 plus x1 square and fx2 is 1 plus x2 square, and we are having x1 is equals to plus minus x2. Therefore fx1 is equals to fx2 doesn't imply x1 equals to x2. We might have x1 is equals to minus x2. For instance, f of 1 is equals to f of minus 1, which is same as 2. Therefore, f is not 1, 1. Now, consider an element minus 2 from codomain set. It is seen that fx is 1 plus x square, which is always positive for every x belongs to the set of reals. Thus, there does not exist any x in the domain set such that fx is equals to minus 2. Therefore, f is not on 2. Hence, f is neither 1, 1 nor on 2. Now, this question. Set A and B, be two sets, show that function from A cross B to B cross A such that f of A comma B defined as is equals to B comma A is bijective function. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So function defined from A cross B to B cross A, domain set is A cross B, codomain set is B cross A, and defined as f of A comma B is equals to B comma A. Solution. Given function defined as f of A comma B to which is equals to B comma A, let two elements from the domain set, so A1 B1 A2 B2 belongs to the domain set A cross B, setting up f of A1 comma B1 is equals to f of A2 comma B2, and by definition of the function, this is nothing but B1 comma A1 and this is nothing but B2 comma A2. As both are ordered pairs, so when two ordered pairs are same, when their corresponding elements are same, meaning B1 B2 same, A1 A2 same. So B1 is equals to B2 and A1 is equals to A2. This gives me A1 comma B1 is same as pair A2 comma B2. Therefore, f is 1 1. Now, taking an element from codomain set, which is B cross A, and element is B comma A, there exists A comma B from the domain set such that f of A comma B is B comma A by the definition of f. Therefore, f is on 2. Hence, the function f defined above is bijective. Clear? This question. Let f from n to n defined by f of n is equals to piecewisely. So when n is odd, then fn is n plus 1 by 2. When n is even, then fn is n by 2. State whether the function bijective. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So function defined from n to n piecewisely, we have to state whether the given function is bijective. Solution. So starting with the given information, fn is equals to n plus 1 by 2 when n is odd, fn is n by 2 when n is even. It can be easily observed what? That f of 1 gives me the output 1 and f of 2 also gives me the output 1. So for two distinct inputs, we are having the same output. Meaning f is not 1 1. Now consider a natural number n from the codomain set. Then Case 1, when n is odd, meaning n will be of the form 2r plus 1, where r belongs to some natural number. Then there exists 4r plus 1 belongs to n, such that f of 4r plus 1 is equals to 2r plus 1. Now case 2, when n is even. So if n is even, meaning n will be of the form 2r, where r is some natural number. Then there exists 4r belongs to n, such that f of 4r is 2r. Therefore f is on 2. Hence f is not bijective function, because f is not 1 1. In order to be a bijective function, the given function must be 1 1 as well as on 2. Here it is not 1 1 but on 2. This question: set A, set of all real except 3, and set B, set of all real except 1 is given to us. Consider function from A to B defined as fx is equals to x minus 2 by x minus 3. So we have to answer, is f 1 1 and on 2? You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So we just have to answer, is the given function from A to B 1 1 and on 2. Solution: set A, which is our domain set, set of all real except 3, and codomain set B, set of all real numbers except 1. Now fx is from A to B as x minus 2 by x minus 3. Let xy belongs to the domain set such that fx is equals to fy. Now fx will be x minus 2 by x minus 3 by definition, and fy will be y minus 2 by y minus 3. Simplifying, we are getting x minus 2 times x, y minus 3 is equals to y minus 2 times x minus 3. Just simplifying it further, we are getting xy minus 3x minus 2y plus 6 is equals to xy minus 3y minus 2x plus 6. Cancelling out the common terms, we are remaining with minus 3x minus 2y is equals to minus 3y minus 2x, which is giving me x is equals to y condition. Therefore f is 1 1. Now for on to, pick any element from the codomain set. Codomain is B. So any real number except 1. So y is any real number but not equals to 1. The function is on 2 if there exists x belongs to the domain such that fx is y. So now fx is equals to y, meaning x minus 2 by x minus 3 is equals to y, meaning x minus 2 is equals to xy minus 3y, gives me x times 1 minus y is equals to minus 3y plus 2. So x is equals to 2 minus 3y by 1 minus y. And this we know x belongs to where? X belongs to set of domain set, which is A here. So satisfying all conditions. So thus for any y belongs to the codomain set, there exists 2 minus 3y by 1 minus y which belongs to the domain set, such that we are having what? F of this input which is equals to y. Therefore, f is onto. So for any element from the codomain set, we are having x of the form, which belongs to the domain set, such that f of x is y. Hence, our function is 1, 1 as well as onto, meaning bijective. Now this question, function from R to R defined as fx is equals to x raised to power 4. We have to choose the correct answer. So option A says f is 1, 1 and onto. B says many 1 and onto. Many 1 meaning not 1, 1. C says 1, 1 but not onto. And D says neither 1, 1 nor onto. You'll have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. So in question, we just have to choose the correct option. Fx defined from R to R, fx is equals to x raised to power 4. Solution. Fx from R to R is defined as fx is equals to x raised to power 4. Taking xy from the domain set and setting up fx is equals to fy, we are having x raised to power 4 is equals to y raised to power 4. And from this condition, we are having x is equals to plus minus y. Therefore, fx1 is equals to fx2 will be same. And this does not imply that x1 is same as x2. For instance, if you pick input 1 and minus 1, the output will be same, but the inputs are not. So not 1, 1. So when you have such case, when for two distinct inputs the output is same, you will immediately say your given function is not 1, 1. Now, if you pick 2 from the codomain set, then we can easily see that there does not exist any x in the domain of which is R such that fx is 2. Therefore, f is not onto. Hence, function f is neither 1, 1 nor onto. The correct option is D, neither 1, 1 nor onto. This question, function from R to R defined as fx is equals to 3x, and we have to choose the correct option. Is the given function 1, 1 as well as onto, or many 1 and onto, or 1, 1 but not onto, or neither 1, 1 nor onto? You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So in question, f defined from R to R, fx is equals to 3x, we have to choose the correct option. Solution. Function from R to R is fx equals to 3x. Taking xy from the domain set, setting up fx is equals to fy gives me 3x is equals to 3y, which gives me x is equals to y condition. So f is 1, 1. Now pick any element from the codomain set which is R. We know there exists x of the form y by 3, which belongs to the domain set such that f of x, which is y by 3, f of y by 3 is y. Therefore, f is onto. Hence, our function is both 1, 1 as well as onto. The correct answer is A. Clear? So this is it from this session. Thank you.